Okay, I've taken chapter 12, and like I told you, I've divided it into 3 sections. So this is the end of the first section of this lecture dealing with Henry's Law. This will actually be the first time we've had a problem in the book related to it. We will not have any quizzes this week, but next week we will. So what we were talking about here, the 7th, 14th through the, 21st through the 25th, we will have quizzes. And then probably 2 quizzes we'll have. We'll have 1 quiz and the quiz after that, and then we'll be ready for a summative after that. We'll see where we're at for that. And there might be a lab associated with this, but I'm struggling to find something that we can do, so we'll probably just go on to the next section of chapter 12. So this deals with the relationship between gas solubility and pressure, where the one we had in the previous lesson dealt with gas solubility and temperature. So this is a linear relationship. Well, I shouldn't say linear, but it's a mathematical relationship that we can associate with in the direct sense. So as solubility increases, pressure increases, or as pressure increases, solubility increases. So we're looking at that relationship right here. One of the ways that we discussed when we're talking about the 3 ways of getting gases to dissolve is by increasing pressure. So the greater the pressure, the greater the solubility of that gas. The concentration can be measured in a number of ways, but the charts generally use grams per liter. And the main reason for that is because gases are so spread apart that they can't be measured like you can with metals, which is grams per cubic centimeter or grams per cc, or liquids, which are measuring grams per milliliter. So since there's a great deal of distance between the particles of a gas, then this is going to have a bigger volume to compare it to in the density. So grams per liter is generally what we're going to use. And when we talk about pressure, there's a number of ways we can do that as well, but we're going to be using the atmosphere. And if you don't recall what an atmosphere is, it's just the pressure of an average day. It's like 29.92 inches of mercury if you ever watch the weather, compared to that, 760 torr, or millimeters of mercury on the barometric barometer, or barometric pressure that we call a barometer. To put all this together, no matter how you measure it, the relationship stays the same. It's S2 over S1 equals P2 over P1, where S2 and S1 represent the solubility of the gas in grams per liter, and P2 and P1 represent the pressure of the gases. So it's fairly straightforward. And you don't have to put S2 over S1, you have S1 over S2 equals P1 over P2. Basically what it's saying is the relationship has got to stay on the same side as where the measurements were taken. So second on top and the first on bottom, or first on top and second on bottom. And this is developed by a British scientist by the name of William Henry in the early 1800s, so they named it after him, Henry's Law. So let's take a look at an example. This is a pretty short section. It's a little plug and play math here. And I suppose at 1.25 atmosphere, a gas has a solubility of 26.5 grams per liter. What would be the solubility of that gas at 8 atmospheres? So we take this formula right here, and we got to figure out what is solubility 2, what is solubility 1, what is pressure 2, what is pressure 1. And so if this is what we're starting with, 1 atmosphere of pressure and 26.5 grams grams per liter is our solubility, then I'm going to make the 1.25 atmospheres P1 and the 26.5 grams per liter S1. This is what would be the solubility of that gas at 8 atmospheres. So this is going to be pressure 2, so that's going to go right over there. And the unknown then is going to be S2. And then we just solve the algebraic problem. Okay, so when you go through all that, you're going to get 25.6 grams per liter over S2 equals 1.25 atmospheres over 8 atmospheres, and S2 then is going to equal to 164 grams when rounded off to 3 significant figures. So this is a pretty simple section, and I think you'll probably have a pretty good foothold on how all this works. The quizzes, you're going to need to know even though we didn't have a practice problem, but you will need to know how we make things dissolve, because that may be asked of you. Anything that we talk about will be asked of you in the quiz, so make sure you are pretty familiar with what I'm asking you to know based upon the scripts that you have, or just by listening to the videos again. Scripts are pretty handy. You can just write notes on it and circle stuff that you feel are important to be prepared for the quizzes and the summatives at the end. All right, there you go. Good luck.